Hi, how to identify and deal with outliers. So before we learn how to identify and fix the outliers, we need to understand the impact of outliers. If outliers are present in your dataset, they can inflate or deflate the mean. For example, if your variable is measured on a Likert scale of 5 points, 1 to 5, and an outlier is present, and value of the outlier is 55, naturally, your mean value of that variable will be inflated grossly. Similarly, in the same variable, if a value is an outlier is present with a value of minus 45, then obviously a mean value would be deflated. Second consequence of the outlier is that they can pull the mean away from the median, and they can distort the distribution of data, and they can mislead the use of the results also. So that's why it's very dangerous that if your data set is containing outliers and without fixing the outliers, you run the analysis, it is highly risky. So now the question arises how to identify them. Let me make a demonstration. So go to your data set. So here is a data set. So go to analyze. So this data is the age of employees. Analyze, then descriptive statistics, then explore, and select the variables and add it in the dependent list. Check the option of statistics and plots. Click it OK. Now you would see the first table contains the summary. The number of valid cases are 12, missing values are nil, and total cases are 12. Then these are the descriptive statistics. So the mean is 34. So the median is 24.5. We need to record it somewhere. And then you see skewness is 3.3 and kurtosis is 11.277. So data distribution is also very problematic here. Now let's move towards the box plot. So this is the box plot. In the box plot, if you see, so it clearly shows there are two outliers. One is present in case number 5 and second one is present in case number 12. It's also showing so what is the value of these outliers. So let's see number 5 and number 12. Number 5 is 12 and number 12 is 145. And obviously these two values are really irrational and unrealistic. No employee can have age of 12 or 145. Now the question arises how to fix these problems. First, carefully examine the data points and identify the outliers as we did. Identify why outliers exist. So we need to cross-check whether these values are genuine or someone mistakenly typed it in the dataset during entry process or any other reason could be there. Then we need to take action. Then rerun the outlier analysis. Let's learn how to take the action. So there are three options available with us. Option number 1 is delete the value. If the outlier is truly abnormal and not representative of your population, then it's okay to remove it, just like in our case. So age of 12 and age of 145, they are not representative of the dataset. So both can be removed. Second option is delete the variable or the case. If you feel the question was poorly constructed, or if there are too many outliers in that variable, so these two reasons justify that that variable should be deleted. Or in case many outliers are present in any single case or few cases, so those cases can be considered for removal. However, in our case there is only single variable. Obviously we cannot remove the neither case nor the variable. Variable cannot be removed because there is a single variable, and case cannot be removed because if we remove two cases, then data would be reduced. Option 3, transform the value. Change the value to the next non-outlier highest value, or change the value to the next outlier and plus add 1 or minus 1. So let's see it in SPSS. So these are the values. So what I'm going to do in the first case, I'm going to remove these two values. $12 and $145. Now I'm going to rerun the analysis. Analyze Descriptive Statistics, then explore, and now here we go. So again we have now a new outlier, that is O2. Let's check what it is. O2 36. 30 at the age of 35. So this seems to be an outlier. However, seems a little bit realistic for us. So if we remove it, so again go to statistics and then explore, and then now we don't have any outlier. Now examine the values. Now you see mean value is 24. Earlier it was 34. Median is 24. Earlier was 24. Means only mean was inflated, right? As far as skewness and cutoffs is concerned, you see earlier it was very high. It was 3.3, and cutoffs was 11 point something. So it was very high. Now they are more rational. Okay. Now let's treat the same data set in other way. Let me get back those values. What I'm going to do, value of the 12. So which one is the lowest one? Let me check it in the data set. So in data set, the lowest value is the minimum value is 20. So what I'm going to do is 20. So I'm going to make it 20. And highest value is 35. So I'm going to make it 35. Let's run it. Rerun it. 4. Yeah, there we go. There is no outlier. As far as the values are concerned, so the mean is 25. It's far less than 34. So the median is standing at the same point. Skewness is grossly improved and kurtosis has also grossly improved. Now let's use another option. What we do basically, yeah, so it was 12. So what I'm going to do, since 20 is the lowest value, So I'm going to make it 11 minus 1. At 145 and highest value is 35, I'm going to make it 36. Let's check it. What happens now? In the box plot, you'll see we have again 3 outliers, 5, 2, and 12. That means this method did not work. So this is a way how you identify the outliers and fix them. So thanks for watching.